So the topic today is AutoCAD 2026, Unlock Precision in AutoCAD, Smarter Annotation and Dimensioning for AEC Professionals. Take your drafting accuracy to the next level with the full AutoCAD. The purpose of this webinar is to emphasize the benefit that you're going to get if you use the full AutoCAD version more than AutoCAD LT. So today we're going to show the thousands of AEC firms. So why I'm moving from AutoCAD LT to full AutoCAD, because real precision in construction document isn't optional anymore. Agenda today is why precision failure costs AEC projects millions, and AutoCAD LT versus full AutoCAD, the hidden limitations, and 5 game-changing precision tools only in full AutoCAD. This one, the third section, I emphasize you because I show you live in the software or in order to you to see the powerful of the full AutoCAD. And how to justify the upgrade to management and Q&A. Okay. The real cost of close enough in AEC 2023 FMI is short for failure mode identifier study. 37% of rework come from dimension coordination errors. Average rework costs 9 to 12% of project value. One wrong dimension on a structural drawing, weeks of delay, and manual re-annotation after design changes equal to 20 to 40 hours per sheet set. These are the theoretical numbers. They come from owners, GCs, and engineering firms we work with daily. AutoCAD LT versus full AutoCAD, the precision gap. So the comparison chart showing that in parametric constraint, AutoCAD LT can't do at all, and full AutoCAD surely can do. And dynamic block editable, AutoCAD LT can do just static, only can't do the dynamic block, but full AutoCAD can do fully dynamic. And I will show you live in the next section. And associative arrays, AutoCAD LT still no, can do, but for AutoCAD, yes. Geometric dimension, no. Constraints, AutoCAD LT can't do at all. For AutoCAD can do, surely. And data extraction and linking, AutoCAD LT can do just a very limited, but for AutoCAD can do full. And action parameters in block, I will show you later. So tool number 1 is parametric constraint, the heart of intelligent drawings, the force parallelism, perpendicularity, tangency automatically, horizontal, vertical, coincident, concentric, etc. When one element moves, everything else obeys the rules. In AEC, wall moves, grid shift, constraint, keep everything coordinated without manual fix. So this one I will show you live in the software. So I switch, please give me a moment to switch to the software. Okay, I will show you live in the software here. This one. I try to show you first what exactly the dimensional parametric constraint. In this tab, AutoCAD LT doesn't have, but full AutoCAD, this one is full AutoCAD. It has the parametric tab showing here, and constraint is over here. The powerful of it is that I will create from the scratch drawing, and I turn off the grid line. I assume that you all have the experience of AutoCAD before, so I will showing you at a professional level. First of all, we're gonna do is, for example, I write something messy here, draw a very unaligned line. So I want to close this one. The technique is that I use the fillet and hold the shift key here. We can make the corner easily like this. So this one, I need this line to be vertically, and then this one we call horizontal line. How can I do it? In parametric, we can do by using the constraint horizontal and apply to this line. You can see that this line gonna be the horizontal line exactly. This one as well, I need it to be vertical. This one also here. And in another alternative, we can do the parallel as well. The first one is the reference line here. The next one is the line that have to be adjusted to be parallel with the reference line. You can see here. And every line that had constraint applied on it, you can see that it has the button showing the constraint that apply to this line. So this line has been applied with two constraints, the vertical and parallel here. And this one as well, I need to be horizontal here. And surely we still can do the fillet corner to keep the line connect each other in the corner here. Very easy like this. Someone think that do I have to apply all the constraints to all the line? Yes, if you need it fully constrained, but it's not necessary. Maybe you think just some line that you want to constrain, you can do just a portion of it. Here, you can see that we can adjust the shape to be more neat than before. And this one as well, I need to be vertical. This one I need to apply, and I can adjust, but I can't stretch or move the line away from the vertical constraint. You can see here, as normally when we have the line here, I click on the clip at the end, I can stretch away. It's work like a rubber band. I can change the direction, I can change the length to which way as I need. But this one, after we apply the constraint, we can't move away. We have to maintain the direction, but we can change just the length only because the length doesn't have constraint on it. Okay. Here's the benefit that we're gonna get because we can constrain the line, and then after we finish geometric constraint, we still can apply the dimensional constraint after this. And you can see that we can destroy the constraint anytime by right click and delete. That means this line don't have the constraint on it anymore. So I can change the direction. So you can add and you can delete the constraint whenever you need. So, and the constraint that had the benefit is that when I have two sides of circles, I need the circle, I adjust to smaller in order to be easy to understand, and then I apply the equal constraint. Remember, the first one is a reference, so this one as a reference. So the smaller gonna be bigger when I apply on it. You see? And vice versa. If I apply the equal constraint on this one at the reference, and this one had to be adjusted to the smaller size. It's easy like this, and you can see that it had a pair of the constraint on both circles linking each other. When you delete the constraint from one circle, another circle gonna be deleted as well. but I can undo. And here we go. We can move the circle inside the shape, whatever shape. It's work like a block of something, or the house, or any machine in the building, whatever you can apply. The next thing that I need to show is that hide all. When you move the cursor, when you zoom out to a smaller shape, and when you hover the mouse, you can see that it has a pop up of the constraint. Sometimes it's quite messy. You can hide all. You can see now hide the constraint all, but the line still constrained, have the constraint on it here, and you can show back, show all here. You can switch off and on like this. Okay, and we have the infer constraint. What does it mean, infer constraint? Normally, when we draw the rectangle here, you can see that the system gonna apply all the constraint automatically when you hit this button. Okay, but it's different if you turn off this button. When you draw the rectangle, nothing constraint on it. So it's different. Infer constraint is mean automatically apply the constraint on the shape that you decide. And what the benefit? You see, this rectangle have constraint on it. When you move anything, it move with the maintain the shape of rectangle. You can't change the shape of rectangle. It's still rectangle all the time. You see, this is a benefit of constraint that LT can't do at all. However, if you want to adjust this rectangle to be square, it's just easy. You apply the linear constraint. Normally, we apply the equal constraint. Square, that means the horizontal and vertical equally, right? I apply the equal constraint first, and then I apply the linear constraint. Dimensional, we apply the object to object this one. You see, the system will show 58. I need to change to 60, enter. You see, the shape still maintain the square, but we can change just the number only. This is the we call dimensional constraint. This is the geometrical constraint, geometric constraint, dimensional constraint. We apply the geometric constraint first, and then the second is dimensional constraint. After that, we can change by dragging the hot clip, whatever, right? It's easy like this. This is the benefit. And we can apply the formula. For example, if we apply the linear constraint here, to the middle, to the center of the circle here, and this one gonna be 40. But I need the distance of this equal to half of the dimension E2. For example, I click on the 40 and I add divided by 2. That means this distance gonna be 20. And you can see that the gap happen. You can apply the coincident constraint. This is the reference. This is the point that's gonna move here. And you can see that this distance gonna be half of D2 all the time, because when you adjust the number of 40 to 50, this one gonna be 25. Surely, yeah. You can see or we can change divided by 2 to divided by 3. Yeah, like this. This is the benefit of using the constraint, because you can keep the relation between among the lines. Okay. In the work that you need everything constraint, everything keep the shape, anything. Because in 2D only, when you adjust something, you the relation may be is missing and you have the messy line. So for the work that you do all the time is that when you're doing the grid line, right, or the wall, you make the grid line. And you need the wall to attach to the grid, right? How can you do? You do this by apply the collinear. This one as a reference, this one is the line to move to be attached to the reference. And you, I need to change this line to color. I change to the green color. Okay, cyan color, in order to differentiate. And then I apply the collinear. This one, collinear, this one, collinear, this one. Oh, sorry, collinear, this one here. And when you move the grid to another side, this one you can apply the vertical to the grid. Okay, when you move the grid, okay, this one gonna be horizontal as well, as much as you can. And when you change the grid, anything, you move the grid. You can see that we have the relation among these lines. The wall attached to the grid. When you move the grid, the wall attached. Assume this is the wall, right? The wall. When you want to make the wall, finally, this is for the conceptual idea. And after that, you can apply the offset to the rectangle in order to have the wall thickness like this. But this one should be at the latest work period of work, because this line is no relation on it, right? Yeah, this one is this kind of application that we use the parametric constraint. And when we need to delete the constraint, just easy. Delete constraint and crop on all. Enter. Or the line free again. So you can move freely here because the constraint gone. Okay. And parameter manager here, you can see that we have 3-dimensional constraint. This one, D2 is equal to 50. D3 had the relation, that means D2 divided by 3, that means 50 divided by 3 equal to 16.6667 here. You can see they had the calculator for you to calculate the value. This is clear about the dimensional and geometric constraint, that the benefit more than normal LT. Okay. The next thing I want to show is the dynamic block. I think it's the highlight of this day, because the geometry that we do a lot is a block, right? So I need to create some line. I need to create from scratch because we still have time. So I show you from scratch live so that you can see every step. So this one I need to create the 800 door. Okay, I move to away to around here. And then I create the line at the center. Use the CEN. Okay. We use the center. Okay. Here. Turn on here. And I offset 50, the thickness of the door leaf. And then I trim all to make the door. Okay. This one. It's just a simple door. And we would like to make this door to be dynamic block. We can change the size because we need to be to create the family door. Okay. First of all, we need to create the block. Here. We call this one door. And we pick this DVC insertion point and select all the line to be door. And we need to open in block editor and we would like to delete this block. Okay. Here we go. We get in the block editor. And then the thing that we need to do is the parameter flip. You can see here is a flip. I need to clear the flip between the mid between 2 points, this point and this point. Around this and flip state 1. And the action is that I want to flip because when we apply the parameter and we close the block editor, save the change and get outside, I need to insert the block here. This is the dynamic block, but you can't see anything changes because parameter would come with the action. So I get back into a block editor again. We still have to apply the action flip here, click on the flip parameter and then select all the door. Enter. This time it's different. So you can change the flip between the door. LT can't do like this. Full AutoCAD can do just AutoCAD, just full AutoCAD. Yeah, easy, right? Flip the side. And also we need to flip vertically. So we apply the parameter flip again on the left side. Flip here to here, flip state 2. And we need to apply the action of flip again. Select this one, select all, flip. Okay, here we go. We can flip vertically here, left and right. Vertically, left and right, right? Very easy, right? When we do the block editor again, so we need to apply more parameter set. We call the linear stretch. We need to apply the linear stretch here to here with the distance. And we have the constraint. We can use the knowledge of constraint, stretch here, right click, action selection set, new selection set, select on around the area and the line that we would like to change. Oh, sorry, because this line gonna be arc, so we have to trim first, trim this line and then connect with the line. Okay, and we're gonna clear the fillet. So we need the horizontal line at the top of the leaf, and then we apply this one action selection set, new selection set, specify corner here, select the line, 3 line, enter. Here we go, change. We have this one, but you can see that the direction is not right. So you go back at here again and click at here, turn on the property. And the property here is, you can see the direction of angle offset should be 90, right? Enter. Save the block out. Okay. Right now, you can change the height of the leaf. You can see the width of the leaf. The leaf here. You see? But the arc gonna be still. You have to figure more with the action parameter, action scale here. You use this parameter to control the scale of this arc. Enter here. And when you change, you see, we can change the size of the arc. So we can adjust the size of the door to whatever size. That's quite easy for us. We call this the dynamic block. It's quite dynamic, right? And the last step, we need to change the parameter to be list, and we would like to change because freely adjust, maybe the size is not right. So maybe you need to constrain the size to be 1000, 1100, 1200. Okay. We need file size, and we can adjust. It has the indicator, so you can adjust to whatever size you need here without typing anything. You can just move and it locked to the position that you mark on the property list, right? So that means this door we can adjust to file size easily and flip left and right, right? That's quite easy for us to do the dynamic block. This is the next feature that benefit more than AutoCAD LT. So if you're still using AutoCAD LT, maybe this feature can help you a lot. So maybe you concern changing to full AutoCAD. Another thing is that we have the type of the, okay, I will copy this one because I don't want to create from scratch anymore. This one, because this is the visibility hex. You see, we can change the head of the screw from hex, head nut to fillet. Okay, flathead screw. Easy like this. We call this kind of dynamic block the visibility. How can we do this? Okay, I will copy these two. And another here for the reference. And I explode here. And I explode this one change to fillet. And I explode here. Okay. First of all, we need to create the block first. So I create the block for this one. I need to create this and block. Okay, we call the hex head nut. Okay, and then pick the point at the center here. Select here. And turn off the block editor here. And this one, the same. We do the fillet head, flat. Okay, this one gonna be center. and select object, this one. Okay. And then we need to create the block, right? So sometimes we create a circle and we would like to do the block. This one gonna be visibility. Okay, pick the point inside and select here. I would like to open in block editor. Okay. And then I delete this circle because it's not necessary. And then I import. I would like to import the hex here. I move this one at the center. To the location here, we have the trick for you. It's a sharp 0, command 0. Moving to the position of the 0, 0, because you don't have the reference, right? This one, you have to use the sharp symbol in order to order AutoCAD to the absolute coordinate. And this one going to be blocked, right? And then you add the visibility parameter here, visibility, and put it around on the right side. And then after that, this one is auto link palette. You can turn it off when it's obstruct you. And then the visibility state, you call this one, changing the name to hex head, right? And then new again, hide all object, we call this fillet head, right? And then okay. You can see that it turned off the hex head nut, and then you move this one to the position, move this thing to the sharp 0, command 0 picture here, and then close the block here. Very easy to change to fillet, change to hex nut, and you move this one. This one can do the same, hex head and fillet head, right? It hex head, fillet head. Easy like this. You can switch more than the 2, maybe 3, 5, 6, 7, 20, whatever number that you need to do. So that means you can create just one block, so small, and then you can change to whatever shape that you combine all the thing inside your block. Very easy to manage, right? This is the benefit that you're gonna get if you use full AutoCAD. So the next thing that we can do is the extract the information here. When we create the block, so this one, I try to copy to another location. And I need to change this one, edit the block, and then add the attributes. So ATTDEF, that's our command. We can create, I create the sample price, and the prompt is how much. And the default gonna be 100, and then put the property around here, and then change the size of it using the quick properties, maybe 25, 10 times. So we see, compare the size, maybe around here, okay? And then we close the block editor. Save changes. After that, when we delete this one, we would like to insert the door. And here again, you'll see that now prompt is asking you about the price, how much, maybe this one 100. Okay, and you would like to change to the type of 500. We have two types of the door, 100 and 500. And then we would like to extract the information. Maybe I would like to copy more object to here. That means we have two of 500 doors. And then we have just one of 100 door. Then we would like to assume that's the price of the door, right? And we would like to extract. We type the extract. We call the data extraction. And save the drawing first. Okay, demo. Save. And then we would like to create the new data extraction. Next. And then I type AA for keeping the configuration. And then the next. We don't need all the information. We would like just the block with the attribute only. Here, you can see that we filter out to just the block with the attribute only. And then we next, we turn off all the information, just the attribute that we need to extract. Here, we call the price that we custom this attribute by ourselves. And next, you can see that it count. One is mean one single door. The price 100, two door at 500. So we can extract all the information here, and then next. What we would like to do, we need to insert the data extraction table into the drawing, and we need to create the Excel demo as well. Next, and we finish. Here, I will scale this table 10 times 20. Here, you can see we have the information that we extract. So when we create, we put the block on the drawing, we still can extract the information of it. And the question is come when we would like to update. So I would like to copy 500 to more 1 and 100 to more 1. That means 100 should change to 2, right? The counting should be 2 here, should be 3 here. And then I just right click data extraction, update as data extraction. You see the counting changes. The price still the same. Yeah. And when we would like to extract, we can extract again, extract. Data extraction. We would like to update, right? This one AA again. Right down here. Turn off. Okay, and when we extract, you can see that now it's changed, right? And then you next, in this time, I just need to copy. So I would like to copy the part first. Okay, and then create this one, replace it. And I need to open the Excel. So I will switch to the Excel. And you can see that this one gonna be the data that we extract from the drawing here, right? And when we would like to create the calculation, that means we hit the equal, this one, asterisk, this one equal to 200. We have 2 doors of the 100, so total price is the 200. And the same at this one, we just stretch the cell 1,500, and then totally the total cost of us is equal to sum open parenthesis drag close parenthesis enter. Total cost of us is 1,700. It's easy like this to make the quotation, calculation, anything. We can extract the data in the drawing. Here's the benefits of what we have on full AutoCAD. So I think all that I shown gonna hit the what you're facing the problem nowadays, right? The next thing is that we have the associative dimension here. So I need to create another drawing. I will create the rectangle here around here. So normally when we create the dimension, we going to annotate and we create this linear dimension, right? Hit enter, create here. Normally this one is 66.05. We need to change the shape later. You can see that the dimensions still associate with the object, right? Right. This is the benefit that we have on full AutoCAD as well, because we have the associative dimension. So you don't worry about the adjusting the shape, the dimensions still changing along with the object. That's quite easy for us, right? Yeah. Then the next on the other side as well, when we apply the dimension, quick dimension here. So I need to adjust here to this size 0.71 in order to keep this full number, right? And then this one gonna be 0.25. Okay, this 0.25. Okay, we got the full number on both sides. And still associate dimension, you see, very easy, right? But when we would like to change to the unassociated dimension, how can we do it? We have the system variable called dim as soft. Here, if it's showing 2, that means the dimension clearing after this gonna be associated dimension automatically. But when we change to number 1, that means the dimension is not associated. So you just apply the dimension again. When you change the clip, you can see that on the right side, the dimension is still changing, but the left side still stands still at the same. So that means this one is not associated to the shape anymore, just first time creation only. But however, when you would like to change this one to associate again, you call this associate as dimly associate. You type the as associate. You see, the command is dimly associate. You select the dimension that you would like to associate again, enter, and the system gonna ask you about the size of associate. You have to click relatively. That means the top one asking, you need to click on this point, and the other side here. Now, the dimension that unassociate at the beginning, now associate at the last. So you see, very easy like this. So we have the dimensional associativity for you as well in the feature. So you don't have to worry about the associate or the dimension or changing the size and the dimension. You have to change again. That's quite tedious work, but we have the feature to help you to save time and money. Okay, let's get back to the business. I know that you're doing business, right? The thing that you need to keep is three things. The one is save time. The second thing is save money. The third thing is that you need it zero error at all, right? You need three things. So the full AutoCAD support all of your idea. Save time, save money, because this one help you a lot. So save your time, that means save your money in the same time, and reduce error, because when you change the shape, dimension still correct. The correctness still keeping. So you don't have to do it manually anymore, like LT do. So it's a 5 feature today. So I cover it all. And then we have another section for all the feature that quite interesting. And you maybe you join the next section and you're gonna see many powerful info AutoCAD. And right now I have some bonus for you. I'm gonna open the AutoCAD Mechanical in order to show you some, and you're gonna see something that different from you ever see before. Yeah, please give me a moment. Okay, while we're waiting, do you have any question to ask? Please feel free. Any question?
Yes, if you have any question, you can unmute your mic or you can put in the chat box.
Okay, my software launched, so I will switch to, please give me a moment to share on the screen the software. We have another software called AutoCAD Mechanical. This one is different from full AutoCAD. It's an on-top option of full AutoCAD. So that means the base of this software is full AutoCAD. And we add more tools. For example, you can see that we have symmetrical lines, zigzag line, the circle. We have a lot of options. We also have the construction line, a lot of options as well. So this is another choice for you when you're working in the mechanical field. I think this one is more suitable for you than full AutoCAD do. So we work like a 3-step. You know, the first step is AutoCAD LT for the beginner. The second step is full AutoCAD, and this one, the last one, is the vertical product we call the AutoCAD Mechanical.
Sorry, Suton, we have a question in the chat box.
Okay.
You can see.
Let me see. For the attribute made in AutoCAD, can import or use in LT with all the parameters set up, meaning it works in LT even we set it up in full version. So I think it's not work that way, because AutoCAD LT had a limitation because the block in it is static, right? Yes, if you create the static one in full AutoCAD, maybe the attribute is gonna convey. But if you create the dynamic block, LT can't support on that. So the parameter should not go, or it had the error in it, because LT is quite lower than full AutoCAD do. So we urge you to use full AutoCAD instead. Yeah. In parameter is in full version is 100% support. Dynamic no can be used in LT. So when you create on the second step, you should not go back to LT. Okay, LT just the shape, just the line, simple basics. That's it. Okay, any question? No, right? Okay, I will show you in here the symmetrical lines. You can see here, I will create two sides by creating this line. You see, this one is the symmetrical line, so the first line should be center line. The system knowing that. And then the next line should be the full line. Here, 70 divided by 2. Here, 6 here. You can see that I create two sides in the same time. And this one, 24 here. And I would like to create the perpendicular. You see that many of object snap a lot here. So that means you should have the basic of normal AutoCAD first, and then you're going up step to this software. It's quite useful for you here. And you consider about the line weight, right? You think line weight, do I have to do it again? No. This one knowing, so you can check the line weight. You see, the working line is still thicker than the center line. The system knowing that. So you can create all the things within just one command. That's quite save your time and money and reduce error at all, because line weight is an error. When you print it out, you waste your paper, you waste your time, you waste your ink, you waste your electrical, right? Electrics. All wastes if you use just normal AutoCAD or AutoCAD LT. Even for AutoCAD can't support because about the line weight, you have to check manually, right? But this one you don't have to check. And more interesting feature is that layer created for you automatically. When you turn off the AM7, the center line hidden, right? And then when we turn on, the center line coming back. So this kind of command high situation. Okay, another example is that I would like to ask you that when you have some three objects, how fast can you do the hidden line? I assume that the rectangle on top of two circles, how fast can you do the hidden line? 1 second, can you do that? 10 seconds, can you do that? No, right? Maybe a minute, 2 minutes, 10 minutes. It depends on the experience that you have. But in this software, high situation, just one command, select the topmost one. Here we go. All the hidden line created within seconds. And then beyond that, we have the layer provided for you. So when you don't want to see the hidden line, you just turn on and off of the layer, right? Quite useful, right? Beyond of that, when you're changing the shape, here we go. The hidden line still updating. You don't have to painful anymore, because in normal AutoCAD, you have to break the line, break the circle. When you adjust the shape of the square, you have to readjust all the line again from the beginning. That's quite tedious work and hard working. So today we have limited time, so I can't show you all. I just highlighting to be